Greeting learners. So here's another session. We're going to Unit 4. Unit 4, the sum of a geometric series. The formula for determining the sum of terms in a geometric series requires each term in the series to be multiplied by the common ratio. Each term is shifted to the right so that the subtraction of equal values is easier to process. The algebraic proof below applies to all geometric series and is examinable. So you can have this as a question for your metric. So this is what is required to prove. Required to prove Sn is equal to a 1 minus r to the power of n over 1 minus r. This will be equal to a r to the power of n minus 1 over r minus 1, and this is for r must be different to 1. So we're going to prove this. Remember, I've already explained the sum of a geometric series before. It was an arithmetic series. Now it's going to be geometric series. Let's do the proof. So this is what I'm going to do. We're considering that Sn is going to be equal to a plus a r, meaning I'm taking the first term, I'm going to multiply with the common ratio, and then the next one will be a r squared plus dot 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 plus a r to the power of n minus 2 plus a r to the power of n minus 1. A to the a times a times r to the power of n minus 1 is practically the last term. So this is 1. I'm going to consider this sum multiplied by the common ratio. So I'll be having r times Sn is going to be equal. I'm taking this first term multiplied by the common ratio, then I'll get the next one, ar plus ar squared. The next one which is going to follow here is going to be r to the power of 3 and so on, and then dot dot. Then I'm going to have a to the power of r to the power of n minus 2 plus a r to the power of n minus 1. And the last one, when I multiply this by the common ratio, I'll be getting a times r to the power of n. This is going to be the second sum multiplying the first one by the common ratio. So I'm having here 1. So I'm underlining down here, we're going to take the first sum minus the second one. So this is what we're going to get. Sn minus r times Sn, which will be equal to, as you can see, AR minus AR, we're going to get 0. AR squared minus AR squared, we're going to get 0. Till we're going to reach to this one, and we're only going to remain with the A, and this one here will be minus A times R to the power of N. All of this in the middle will be given 0. So I'm going to factorize here. I'm going to factorize Sn being a common factor. So I'll be having 1 minus r times Sn, which will be equal to a minus a times r to the power of n. In the second, the other side, we're having 1 minus r times Sn. A will be also factorized here. We're going to have 1 minus r to the power of n. As we want to get the sum here, our Sn will be equal to a times 1 minus r to the power n over 1 minus r. And this will be equal to a times r to the power n minus 1 over r minus 1. And this is for r different to 1. So we have finished the proof. If we want to take this second sum, we can consider 2 minus 1. We have done here 1 minus 2. This is what we are getting. So now if you take 2 minus 1, we'll be having r times Sn minus Sn. Then we're going to get this second expression. By the way, it's the same sum, because if you multiply this one times negative 1, you will get the second formula here. So we are done with the proof. I'm going to consider a worked example concerning this sum of geometric series for practice so that you can understand very well. But this can be a question for your exam. Make sure you understand this very well, and you must be able to do it by yourself. So let's take a worked example now. Okay, so here's the worked example number 1. Determine the sum of terms in the series 5 plus 10 plus 20 plus 40 plus dot dot plus 655,360. So we want to get the sum of the terms of this series. As we can see here, our first term is 5, and if we want to get the common ratio, is going to be 10 over 5, and this is going to be equal to 20 over 10. Then it will be equal to 2. Our common ratio is 2. So the formula for the general term, Tn is equal to a times r to the power of n. And our last term is here, 655,360. We want to determine the sum. And if we want to determine the sum, as we have seen it, I'm going to remind the formula we got here. Sn is equal to a 1 minus r to the power of n over 1 minus r. So that's what our common ratio is already there. Now we need to get the number of terms of our series. So Tn is equal to, our a is 5, and our common ratio is 2 times 2 to the power of n minus 1. As we can see in our series here, the last term is 655,360. We're going to write it down here. 5 times 2 to the power of n minus 1. This will be equal to 665,360. We're going to divide both sides by 5, and this is going to be easy for us to get the value of n. Then using my calculator, 655,360 divided by 5, then we're getting 131,072. So here, dividing by 5 here, divide by 5 here, divide by 5, 2 to the power of n minus 1 will be equal to 131,072. So now, we're going to try and see if this number is a power of 2. Using my calculator, I want to express this number as a power of 2. 131,072. Let's check 2 to the power of 16. Now that one is not working. To the power of 17. Then we get this. So So we are having 2 to the power of n minus 1 is going to be equal to 2 to the power of 17. Now, equating the exponent, n minus 1 is equal to 17. Our n will be 17 plus 1. So our n is 18. Now, we're trying to get the sum of the terms in this series. Our formula is here. So our n is practically 18. So S18 will be equal to, first term is 5, 1 minus the common ratio is 2 to the power of 18 over 1 minus 2. And with this, we're going to go straight to our calculator. 5 times 1 minus 2 to the power of 18 over 1 minus 2. And our final answer is 1 million. Let me write the answer. S18 is equal to 1,310,715. This is our sum. So we're done practically with this first example. Determine the sum of terms in the series. Here's our series. First term is 5. Our common ratio is 2. Getting the general term, we are comparing this formula to this 655,360. We end up getting that the number of terms is 18, and our sum S18 is here 1,310,715. We are done with the first example, so we're going to take the second one. Let's clean the board. Here's the second worked example. The first term of a geometric series is 16, and the sum of the second term and third term is 12. Determine the sum of the first terms. Determine the sum of the first 10 terms. Let's go to the solution. If we want to get the sum of the first 10 terms, we need to get the 10 terms so that it's going to be easy for us to get the sum of the geometric series. Our first term, as they are saying here, A is equal to 16. The sum of the second term and the third, T2 plus T3, this is equal to 12. So this is going to help us to get the terms, and then we will be going to the sum. I'm going to replace, here we know the formula, let me remind it always. Tn is equal to A times R to the power A n minus 1. So T2 it means AR plus T3, AR squared is equal to 12. We know the value of A, and this will imply that 16R plus 16R squared is equal to 12. As you can see here, we're going to take a common factor to 16 and 12, and that is going to be 4. So we'll divide all the terms here by 4. Dividing by 4 here, we're getting 4R plus 4R squared is equal to 3. Then we will be dealing with the quadratic equations here. We're going to have 4 r squared plus 4r minus 3 is equal to 0. Remember, you know how to solve a quadratic equation. I'm going to use a factorization method here to get the value of r. So here, what are we going to do? We need to get two numbers. One's sum will be 4, and one's product will be 4 times negative 3. Then we're going to be having negative 12. These two numbers will be 6 times 2. We get 12, but the product is negative 12, and the sum is 4. So here it's going to be 6 times negative 2. Then factorizing will be having 4 r squared plus 6r minus 2r minus 3 is equal to 0. We're going to group the first two here. Here we will factorize 2r, then we'll remain with 2r plus 3 minus 2r plus 3 is equal to 0. Then we end up getting 2r minus 1 times 2r plus 3 is equal to 0. And the value of r here, for the first one, 2r minus 1 is equal to 0. Our r will be equal to 1 over 2. And the other one is 2r plus 3 is equal to 0. The value of r here will be minus 3 over 2. So we're having r is equal to negative 3 minus 3 over 2. So now, getting the sum of the first 10 tens, we're going to use the formula. First, we will consider r is equal to 1 over 2. And the S10, first 10, S10 will be equal to, the first 10 is 16 times 1 minus r. Here is our r is considering 1 over 2 to the power of n minus 1. Here is going to be 10 minus 1. We get our formula is 1 minus r to the power of n. And our n here is 10 over 1 minus 1 over 2. Then we're going to use a calculator to get this sum. S10 will be equal to 16 1 minus 1 over 2 bracket to the power of 10, and then we're gonna go down to the bracket, divide by 1 minus 1 over 2, and then we're getting 1023 over 32. So the first answer here is 1023 over 32. This is S10 for r is equal to 1 over 2. Now we're going to consider the second value. The second value is negative 3 over 2. So when our r is equal to negative 3 over 2, S10 will be equal to 16 1 minus 3 over 2 to the power of 10, and this will be 1 minus 1 over 3. And let's take our calculator now. So we're going to have 16 multiplied by 1 minus 3 over 2 close brackets to the power of 10 and down 1 plus 3 over 2, and this is gonna give us, okay, so the final answer is negative S10 is equal to negative 11,605 over 32. This is the sum of the series. So here's worked example number 2. We are done. Determine the sum of the first 10 terms. For the common ratio 1 over 2, this is the sum. And for the common ratio negative 3 over 2, this is the sum. We have practically covered 2 worked examples. Now we're going to take an exercise for the next practice. Let me clean the board and then we're going to go to the next exercise. Okay, so here's exercise number 6. We have taken question 4, exercise 6, number 4. Determine the sum of the series 3,125 plus 625 plus 125 plus 25 plus dot dot plus 1 over 625. They want us to determine the sum of this series. So we can see going to the solution. Our A first term is 3,125. And if we want to get the common ratio, it will be 625 divided by 3,125. This will be equal to 125 over 625. So how much is this going to be? Let's use our calculator. 625 over 3,125. This is going to be equal to 1 over 5. 125 over 625, we're getting 1 over 5. So our common ratio is 1 over 5. Now, our last term, Tn is 1 over 600. So here I'm going to write Tn is equal to A times R to the power n minus 1. Then we'll be having our first term is 3,125 multiplied by the common ratio is 1 over 5 to the power n minus 1, and this will be equal to 1 over 625. So using my calculator, I'm going to multiply both sides by 1 over 3,125 so that I'm only going to remain with the bracket 1 over 5 to the power n minus 1. So this is the calculation I'm doing practically. So I'll be writing 1 over 5 to the power n minus 1 will be equal. I'm going to multiply this by 1 over 3125. 625 multiply by 1 over 3125. Then I'm getting this. So here is 1 over 1,953,125. So this is what we're having. So I will try and see if this can be written as a power of 5. 1,953,125. Let me see which power this can be. 1 over 5 to the power Okay, so this is giving me 1 over 5 to the power of 9. This will be equal to 1 over 5 to the power of 9. So, equating this exponent, I'm going to have 1 minus 1 is equal to 9, and n will be equal to 10. So now we can calculate the sum of our series. S10 will be equal to, our first term is 3,125, 1 minus, here I'm going to have a square bracket, 1 over 5 to the power of 10, and this will be 1 minus 1 over 5. So I'm going to take my calculator now. My calculator, S10, let's calculate 3,125 times 1 minus 1 over 5 to the power of 10, and this yeah, still doing my calculation. Okay, down 1 minus 1 over 5. And our final answer is a decimal number. We're getting 3,906,2496. So I'm going to round off to 2 decimal places. Then we're going to get 3,906,25. Yeah, so I've rounded off to 2 decimal places because we're getting a decimal number. So we have practically covered this exercise number 6. I think you have understood. I've taken 2 worked example and 1 exercise. It's enough for you to practice and understand this. Thank you. Thanks for watching. Don't forget to subscribe, like, comment, and share the video if you learned something. Thank you. See you next time.